Hi viewers, this is Sri Ramulu. So today's topic is conductivity, right? In order, in ordinary conductors like metals, the conductivity decreases with the increase in temperature. Okay, when we increase the temperature, what happens? Their conductivity decreases. Why? Because large number of electrons already in conductors, metals, electrons have the free electrons, they move in random direction. So when we apply the heat, again their randomness increases. When the randomness increases, then current will decreases. Decreasing current indicates increasing in resistance. Okay, decrease with increasing temperature. The scattering of electrons means, scattering means different direction has to move. Electron increases with rising temperature, that is the thing. Okay, scattering means electron move like this in all directions, so easily they collide with the other electrons and their speed lower down, then resistance increases, conductivity decreases. Temperature, and as a result conductivity of conductors decreases and resistance increases, that is the thing. So such material shows the positive temperature coefficient. So that is positive temperature coefficient. Why it is a positive temperature coefficient? As the temperature increases, resistance also increasing. So simultaneous both are increasing positive. If one is increasing, other decreasing indicated in the physics with minus. We denote with minus. Minus indicate decrease. But here what happens when temperature increasing, resistance also increasing. So proportionality. So it is a positive temperature coefficient. In semiconductor, the density of charge carriers increases with increasing temperature, and as a result resistance decreases. See, up to conductor, okay, here up to conductor, but in semiconductor from here, so see, in semiconductor the density of charge carriers increases, means more number of charge carriers like electrons or holes increases with increasing the temperature, means more number of electron hole pair increases. As a result, more electrons moves in, means they moving of electron is called conductivity or conduction. So when they move, then what happens? Conductivity increases. As a result, what happens? Their resistivity decreases. Conductivity increasing means resistivity decreases, means their resistance decreases. Hence, semiconductor shows negative temperature coefficient. Why? As the temperature increasing, resistance what happens? Decreasing. So opposite is denoted by minus. Okay. The conduction in semiconductor is due to two mechanisms. See, in semiconductor, because of conductivity or motion of the electron is in semiconductor is because of two things. Two mechanisms are there. One is drift, other one is diffusion. What is a drift and diffusion? First, drift. The motion of charge carriers in semiconductor is not in specific direction. Okay, motion of charge carriers in semiconductor is not in specific direction. Specific, not in specific direction means, suppose it is in semiconductor, this electron may move like this and another electron like this and like this. So that is not in specific, means in random direction. That is not in specific direction but is at random, that is the thing, and hence net current flow is zero. Yes. Okay, one electron is coming in this direction, other one is moving in this direction, they collide, then this they stop. Current what happens? Zero. When voltage is applied or electric field, either voltage or electric field is applied across semiconductor, electrons and holes move towards opposite and a negative terminal of the battery and constitute a current flow. Okay, so here electrons moves towards the positive terminal and hole moves towards the negative terminal, then they constitute a current. This type of current is called drift current. So that is called drifting means what we are doing, we are applying the voltage or electric field to move the electrons or holes in specific direction. Okay, so movement of electron in specific direction is called drifting. Okay, and current is because of this is called drift to current. The current density J is proportional to applied electric field. So if you increase the electric field, their specific direction also increases. When specific direction increases, current increases. Increasing current indicates increasing in density, current density. Why? Current density and current relation is what? J is equals to I by A. This is the relation between current and current density. Current per unit area is called current density. Okay. Suppose, okay, remove directly proportionality constant. Then write one constant. That constant is mu and equal is written. So J is equals to mu E. But here let there are the n number of let there are the x number. X means 20 or 30 electrons. That is x. Okay, now it is this generally if you do not write anything, just J is equals to mu. It is for single electrons only. For more electrons it is x mu E. So their charge also we have to include. So charge is q. So like this, likewise this formula has come. Why? Positive charges are there, negative charges are there. So that is why we have to add q value also. Where x is the number of electrons are whole. Q is either x is either electrons or whole. Q is a charge. Mu is the mobility of charge carriers. Mu is called mobility of charge carriers. If the conductivity is due to both, okay, both means due to electrons, holes, electrons and holes, then the current density is, see, so due to the current electrons, current density is equals to mu n q n mu n E, and due to the hole qp mu p E. So total or net current density is this because of holes and electrons. So it is fine. Where mu p mu n are the mobility of charge carriers or electrons and holes. Holes and electrons. It is hole, it is for electron. Okay. And a sigma, conductivity sigma is equals to J by E. J value is this, substitute here. So then we get this one. So it is what? Conductivity. Next, because of diffusion, from two mechanism, one is a drift to, other one is a diffusion. So what is a diffusion? Diffusion is the process of movement of charge carriers from high density region to low density region. Okay, suppose if we have prepared a n type or a p type material, okay, so let it is n type material. So one side is a highly doped, this side is highly doped, and this side is a lightly doped. Then what happens? The charge carriers from the high doped region travels towards a low doped region. Okay, so they have to move in this direction. So in this direction their distance is from this side to this side increasing. When distance increasing, density decreases. Why? High density here, here low density, high concentration, low concentration. As the distance increases, the density decreases. Okay, this process generally called diffusion. Diffusion occurs whenever a particular gradient is excited. In semiconductor, diffusion occurs due to change in density of charge carriers and cause further diffusion in semiconductor. Okay, change in charge carriers. Okay, density of charge carriers, high density to low density region changing. The process of diffusion takes place due to statistical distribution rather than Coulombic attraction. So they cannot follow the Coulomb attraction or repulsion force. They follow the statistical distribution. Statistical distribution means like Fermi, Dirac, or Bose-Einstein. So they distribute. They follow those distributions only. But here electrons can obey Fermi-Dirac rules. So current density is directly proportional to what? It is directly proportional to dN by dx. dN by dx is called N stands for hole. Oh, sorry, electron. Electron gradient we call. Okay. So why? dN by x, dx, x is there. And here remove the directly proportionality and attach one constant. That constant is the dn, diffusion. D stands for diffusion. Okay, where dn is a diffusion constant of electron and dn by dx is represent the gradient of electron density along x axis. Here x is there only in one direction. A negative indicates a decrease in density due to increase in distance. I said you just now. Okay, so when distance moves higher density region to lower density region, if you move like this, the distance is increasing, then what happens? Density decreases. And when an electric field is applied across a semiconductor, both drift and a diffusion takes place at the same time. Okay, so both can take place at the same time. If jn here, jp and jn here represents holes, and here it is holes, jp it is there, holes and electron densities respectively, then jp is equals to add. So what are things we have to add? Drift formula and diffusion formula we have to add. So it is a diffusion formula. Already drift formula we calculated, that is this one. Okay, so this is and this is for electrons, so replace p by n, then it is. So okay friends, these are the two equations, major equations for conductivity. Okay, thank you friends.